Hallo Freunde, es ist 10 Uhr, mehr oder weniger, in Redmond. Also, es ist Zeit für .NET API Review. Wir haben weniger, no, wieder Rot Issue. Äh, Los geht's. Alrighty. Stuttered on a preposition, but I think my German's getting better. Despite the fact that read-only collections is on top, we promised an agenda item first of add GPIO pin to GPIO controller in .NET IoT. This is IoT issue 1920. Your guys' numbers are so small. All right. So who wants to talk us through this one?
I could do a brief introduction, and then I think Laurent is gonna be the main driver of the actual proposal. But I think, I just want to kind of like set the stage because I think it kind of will help with the discussion. So back 3 years ago when we introduced .NET IoT, there's two main concepts, right? So there's the controller, which essentially represents a board. So like let's say your Raspberry Pi. Um, and in it has like pins, right? So it has like different pins that you can use to hook up like buttons, LEDs, and stuff like that. So when we were originally designing this API all those 3 years ago, we had two basic proposals. We had one which was like super object oriented, where you had the controller, and then we had a method called open pin, and that would give you back an object called GPIO pin. And then with it, you could interact with it. You could write to in order so that you turn a LED on, for example, or to push a button or something like that. And you could read, so you could detect like events and stuff like that. So that was one approach. The other approach was instead of doing object oriented, be more of a C-like approach where you just have the controller, and then the controller has a controller dot write, and then you pass in like the number of the pin that you want to write to, and then the value that you want to write. And then same goes for read, so controller dot read. So we were evaluating those two possibilities. We thought that maybe it felt more .NET like to have a more object oriented approach. But the problem with that particular approach was that first, it had some issues with ownership management. So for example, for most of these controllers, in terms of the actual implementation, like there's usually some native resources that are held by the controller and that are needed in order to actually perform all the operations in the pen, like writing and reading. So there's that ownership aspect that actually belong to the controller. And so the pin will essentially have to be calling its controller internally to actually perform all of those operations. So that was one thing. And the other one is that the GPIO pin object itself didn't actually have that much state in it. All it was is really just a number, which it means like which pin number it is, but that was it. Like it didn't actually have anything else. So that's why we kind of went with like, in order to avoid all of these ownership, like what happens if you dispose a controller, but you keep the GPIO pin alive? What should happen in that case? And so in order to avoid all of that, we just went with, let's go with a C-like API. So we just have a GPIO controller. We don't have a GPIO pin class. Now, there was one scenario we missed when we were coming up with this design, which is, well, I can mention that a little bit later, but essentially what this proposal is uh, the community and Laurent, they are proposing us to actually like rethink that decision and probably introduce back a GPIO pin class without breaking too much of the existing API, but just adding this additional thing where now you can also have a GPIO pin class. The scenario that we missed is originally we were thinking that like pins could only be provided by a controller, by the same controller. So let's say that you have an LED display and it needs 7 pins in order to control it. Well, we came to the realization that sometimes like those pins, like you only have so many in a board. So sometimes you only have like 20. So if you have a lot of devices connected to it, there are these new things called like GPIO extenders, where now you have kind of like a subcomponent that you connect to the main component and kind of extends and provides way more pins. And so in order to control an LED display, you might want to be using like 3 pins coming from the main controller and then 3 coming from the extender. And so those kinds of things and those kinds of scenarios are actually not that uncommon. They're not super common, but they do happen in the wild. And so it's doable with our current API, but it's really messy. So the proposal in here is if we had these thing called just pin, that it's not only a number, but it's also kind of like I know who my master is, who's providing me or my provider is. Then you can pass an array of this to the device, like an LED display, and then that thing just won't care who's the provider. It'll just work to have a device controlled by a lot of pins coming in from different places. So that's the scenario we missed, and so that's the main driver for this proposal. And so now, with all of that, I've spoken too much. I'll let Laurent drive the actual API that we're trying to add. So
Okay.
take it away.
I think you did most of the summary about that. Something else as well, maybe you forgot to mention, is that even here you see the GPIO controller and the GPIO pin. There is an element that is important behind that. It's the GPIO driver. Okay, and when you create a controller, either you pass a driver, either magically it figures out what driver it is, and the GPIO pin is behind the curtains here, using the driver directly. Okay, so it makes it quite performant as well, because you don't have to go for the controller, etc., etc. In terms of design, if you look at the GPIO controller, the only thing changing is really when you open a pin, rather than returning nothing, this time you return this GPIO pin class. You have the definition of the GPIO class just below. In short, it does allow to do all the standard operation on the pin once it's open, which is changing the mode. Think about either input, either output, so either writing the state of a button, either output, like writing a value to change the status of a LED, and being able to read and write. That's in short about it. We have event as well associated to the GPIO controller. So here as well, there is an event on that you can subscribe for any change. And there is a toggle one, which is very used whenever you're very close to the hardware, because those are operations that can be done in our hardware, not that much in our board. But this one allows you to just change the value normally very fast. Some driver supports, some driver does not support. If they don't support internally, you read write. Otherwise, you just basically use the toggle support. API usage is then very straightforward. The only thing you have to do is the first two lines, like the pin number, creating a new controller, and then opening the pin is exactly the same as you would do today with the current API, except that here, well, you get a GPIO pin, and then from the GPIO pin, you can basically read, write, toggle, do whatever you want with the pin. Something that Jose mentioned and is important is that here you open the pin, and if you look at the definition of our lovely GPIO pin, you don't have any close and you don't have any dispose. Okay, so if you want to close it, or if you want to basically finish clean with this GPIO pin, you still have to close it with the controller. Okay, and we had long discussion about that. Happy to jump in the details if you have more question, but we think because it doesn't hold really any resources, it does not any dispose, and it does not need any close neither. You've opened the pin, you're in charge of closing the pin at the end.
May I add
what?
point?
Yeah, sure. Yeah, sure.
One of the things we discussed is that basically we want to provide a similar experience for both Nano Framework and .NET IoT library. So basically,
yes,
you are working with a small microcontroller, and in the future, it most probably more and more controllers will be able to run .NET because they are getting having more power, and so it's likely to have similar devices that can run more powerful code. I guess that it's likely it's important to have a similar usability, kind of developer experience thing. That's all.
Yeah,
Yes,
and Nano framework
so-
does have GPIO pin. Like that's why
Yes,
that is important.
absolutely. It's the same definition. The class is sealed as well. It's as well a way to align. It add that we've added that before because there were some requests to have the GPIO pin. We've been aligning, by the way, the API between Nano Framework and .NET IoT already like a year and a half ago now, something like that. And so most of the API are almost the exact same, making it very easy to reuse the code. And yes, .NET Nano Framework wants some things like that, ESP32 or STM32, like very small MCUs.
Sorry, I think you said it, but I missed it. So if you close the controller, it closes any unclosed pins. If you want to
Correct.
explicitly close a pin, how do you do that?
You call
So-
control.close and then
Yeah.
you pass a pin number. So that's not changing. Essentially, what we said is like
Is that an existing API? I didn't see it. Is that up above somewhere?
it's an existing API. We
Oh, I
didn't
see.
add an API that particularly takes a GPIO pin for close. So today, close pin takes in a pin number, like an integer.
I see.
We didn't add one that takes in a GPIO pin. That might be something worth doing.
We can add that one, yes.
Yeah.
If that's something you think is interesting, we can add that one, and then I mean it's very straightforward anyway.
Yeah.
Mo.
Yeah, I think I missed it, but like, why did you decide against making GPIO pin disposable that just closes the pin?
We mainly did that because first, GPIO pin itself wouldn't have any native resources. So there's no real need, and it also don't have any fields in itself that are disposable. So it didn't actually made sense to have it disposable. That was one thing. The other thing is we wanted to keep responsibilities for opening and closing directly to the controller, as opposed to like, oh, you open via a controller, but you close it via the actual pin. So those were kind of like the two main reasons why we went with that. And by the way, like I guess this wasn't really mentioned, but if you had obviously this is binary breaking, but it shouldn't be build level breaking, and we intend to not break the existing use. So if people are used to the C-like APIs and they want to still call controller.write, controller.read, they will still be able to do that. This is just adding an additional way of doing things, which I'm not 100% a fan of having like two ways of achieving the same thing. But like this would be just adding this additional way of doing it for that very specific scenario that I called out earlier.
Yeah,
I don't think I completely agree with your earlier assessment that just because you don't have fields at a disposal that it doesn't make sense, because if you basically have a model where you can go up to a type and you effectively have a factory method that gives you a thing that you need to close, I think it makes sense to have that method on the thing you give back, right? It's kind of like saying file.open read, and then you get back a stream writer that you then dispose, right? You don't go back to the file class and say .close with some path, right? So like I think it makes sense that when you have this notion where you have a factory method that gives you back a thing, and then logically that thing is the thing you need to close to make that thing disposable, right?
And would you make it disposable, or would you just have like a close method instead?
Well, I mean, you could do both, right? Which is what we used to do in the framework, right? I think generally speaking, when you call close, there's an expectation you can call open again. So I guess if you go down that path, you should probably have an open method on the GPIO pin that effectively does the same thing as going back to the controller and calling open again, right? Except that you do it on the same instance rather than having to basically get rid of the instance and acquire a brand new instance.
Yeah.
But it kind of depends on your lifetime, right? If you can't do that for whatever reason, then I think it's fine to not have a close method and just say you call dispose, and then once you call dispose, this object is done. If you want to work with the pin again, go back to the controller and get a new one.
Yeah.
We're generally a just shout out meeting, but Patrick, you have your hand up.
Yeah, I actually, this was a discussion point in the issue, and yeah, there are. I think I wrote the pros and cons of having the dispose exactly this, for instance, exactly this pattern using in one of my posts further down in the issue. and together with some other questions.
Yeah, it's done. If you browse down the issue, you have those elements down, a bit down. Yep, yeah, perfect.
Here.
Yeah, here it is.
Here is
And
something.
Patrick, if you want to give the
yeah,
pro
the
cons of
first
discussion.
point, yeah. So yeah, it's pro or con, yeah.
I'm not very convinced by the way to be for the GPIO to be disposable, because at the very end it's just a pin and you can use concurrently from many pieces of the code without having to care too much. I mean, the pin still exists even if you close everything. It's just a pin. You just write something in or out. The open pin is just a way to say, I want this pin to be input or output, but after all, it's there. Nobody is going to destroy it. There is no native resources associated with it. I mean,
the controller won't allow you to do that right now. So
yeah,
currently,
the principle in hardware is that that is this.
You're right, but if you call write on a pin that is not open, you'll get an exception.
Yes, correct, because we have this check on the driver side.
I mean, but that's logically the same as a file, right? If you call close, you don't physically destroy the file. You just basically lose access to said file.
Well, but there is no handle. I mean, the handle is in managed code. There is not native matching.
I mean, sure, but I think from a user standpoint, the experience is exactly the same as if there were a handle, right? If you just use managed code, you don't see handles either, right? But the expectation is you open a file, you can use it. If you close the file, then you get an exception if you start trying to write to it or read from it, right? And that's the same here. So you have to open the pin before you use it. And presumably if you call open pin, you have a pin object, and then somebody calls close pin on the controller, well, then you effectively are in the same state as if you calling a method on the class that you disposed, right? You just get, it's just either get a, I don't know, pin not open exception, or you get like object disposed exception, but logically the model is the same. It just seems weird to me to say, you get to this factory, you get an object that you can then work with, but if you want to basically clean up, then you have to go back to somebody else to ask for the cleanup, right? That's just, it seems to me like an unnatural concept if you have literally a first-class object representing the pin. Like, it seems you want to tie the lifetime to that object.
I get your point, but one of the things is that maybe you have to control a device that has like 8 or 9 pins, and then you end up in having 8 or 9 disposes just because you're using 8 pins. It sounds weird. I mean, usually once you program the controller with certain pins in input as an output, that's it, and you end up in having those pins either in input or in output for the rest of the program, and you don't have to do anything else. Instead, when you have certain devices, you have to pick and poke several pins at once. It looks, I mean, the code is weird to look at it with all those disposes.
So then in normal code, would you expect anybody to ever call a close pin?
If you look at all the Python code or anything in C, you don't have any of the closes for each pin. There is...
The reason is that most people, they open it and then they use the pin up to the end of the program. That's it. Yeah. You really don't change the function of a pin. It's very, very, very rare in the middle. Like if it's connected to a LED, it's connected to a LED. It's not connected to a serial port later on, right? So a pin has one function, and most of the time you'll just open it at the beginning, run your program up to the end, the device is stopped, and that's it. Okay. You still need to have someone cleaning the native resources when you close the program at the end, right? And that's the reason why in the GPIO controller, the GPIO controller will still close all the open pins when you will dispose it. So that's the resources, like the native resources or the system resources, will be clean when you will exit the application.
And by the way, in rare cases, and it's very rare, you may want to use at a certain point the pin is in input and after a while as an output, but it's extremely rare.
That's covered, but you don't have to open it or close it. Like once it's open, you change its status. This is for the one-wire protocols. We have 3 of those one-wire protocols. That's usually a big pain because for many reasons. But yeah, in general, it's connected and the pin remains what it is since the beginning. You usually don't close it anymore.
Yeah,
if you go up a little bit in a page, you will see what you're trying as well to solve with the GPIO pin. So go up. That's what Jose mentioned at the beginning. If you go up in the design part, yes, in there. So in some of the systems, basically, and that's the big block described here, we are lacking GPIOs. So you have extenders. Okay, those extenders are quite popular on some of the system because when you have 2 or 3 or 4, then you use an extender that will give you more than that. And when you want to control, for example, you know, those nice LED panels with a lot of LED, those big ones, you need a lot of GPIOs. So you are using extenders like that. And today, in order to have it working, it's very ugly. I wrote a very simplified version where you basically have to create your own controller. You have 2 controllers or 3 controllers depending on what you have, the one native one, the extender one. You have like different drivers, of course, and then depending on the pin you want to use, because you have to recreate that, you basically have to recreate your own way of putting the pin and playing with all of that. And that's the code that is here. So if you go a bit more down on that one, the first one shows how you have to do today. So it's quite ugly, and then you have to do basically the GPIO controller and create a GPIO controller with different drivers and have a lot of things internally done. If you go then a bit more down, you will see the version with the GPIO controller, which the GPIO pin, sorry, which then is very simple. You just basically create a list of pins and you are good to go. And you just open them, put them in a list, for example, and that's it. So it's simplified a lot how you use those extenders. And this is the main case that we have where GPIO pins really make a difference as well in terms of performance, because in this case, you directly have the driver. You don't have to go back to the controller, know which controller it is, open whatever. Yeah, it's directly there. And that's just to complete.
Isn't that another case where having a dispose is easier? Because if you have a dispose, you don't need to know which controller the pin came from. You just call dispose on it, right? In this model, you would still have to know which close method you would have to call, right?
Well, in this case, I would point to the previous point, right? Then here you have my device. You do whatever with your device. You close your code. You close the 2 controllers, or you dispose the 2 controllers, and it closes everything, and you're good to go.
Yeah, disposing the controller will always dispose,
always
like essentially dispose the pins as well. So I guess like the first.
Some context. The one of the extenders, for example, give you 16 pins, and I don't think that anybody would be happy to make 16 disposes instead of 1. That's the point.
Yeah, I mean the biggest so if the pattern was always you call open, you do some things, and then you have to call close, then I would say it should be disposable. We've even added a guideline that suggests that if you always have to do this pair of operations in order to be correct, that iDisposable is a good way to do that. But if what you're saying is in general, people don't close pins, they either run until their program terminates or they close an entire controller, then this maybe feels more like a scoped view, like cancellation token over cancellation token source. The source is disposable, the token is not. So.
Yeah, it's very, and you're right. It's very much like that indeed. And then, I mean, even in samples, etc., you never see people closing the pin at the end. You just even don't see anything. It's like you close the controller and it closes like all the pin you've opened always. It's Very rare
This-
people are closing them because there's no advantage to do it.
This would even go a bit into the direction of the other discussion about the should dispose argument, which we have in many bindings right now.
Yeah.
This would mean that we probably currently rather don't do that and make it customary not to dispose the pins.
Yes, what we do in the so yeah, to give a little bit of context on what Patrick says, we have bindings, what we call bindings. Think of it as driver to drive, I don't know, like an accelerometer or magnometer or a small screen, right? Here you pass a GPIO controller or no GPIO controller. And we give the option to people, for those ones using GPIO controllers, to pass their own GPIO controller or to create a GPIO controller with a default driver. And when they pass it, we give the options to dispose it at the end or not, for example. Those are elements like that we do. Few reasons for that. If you are using a GPIO controller and you have 5 of those bindings, you don't want it to be disposed at the end of the first one, because most likely, the others may be using the other ones, and you may use one just for, I don't know, blinking your LED 5 times, and then you never want to use it again. So we have things like that you have to take in consideration as well.
One more thing is that most of the programming dealing with the IoT is event-driven. So basically, even if you run an ASP.NET Core application, you have a background service, and you just wait for something to happen. And once it happens, you just react to the sensor. So you do something based on that. And so this is why you basically set up your board, you do something, and just you wait indefinitely until you have to close everything. And having the possibility to close once and for all, it's normally the choice that everyone makes.
Imo?
What happens when I call open twice?
You end up with an exception.
No, it doesn't throw an exception. Like if you call open on a controller for the same pin twice, it
I
won't.
think you get an exception.
No, the second one is a no op, I'm pretty sure.
So do you get back the same instance, or do you get back a different instance that just is bound to the same pin?
Well, so the thing is, before this, you wouldn't get back anything, right? So
Right.
before this, it was just a C-like API, so it wouldn't throw an exception. You would try to open a pin in a mode, and then you're trying to open it again. We would if it's already open and it's in that mode, it would turn into a no.
If
The mode is
pin would
different,
be
it just is
open-
the same
Wait,
as
wait, wait.
calling set pin mode then?
Exactly.
Just checked. If you try to open it a second time, you'll get an exception. I copy the permalink in the chat.
Well,
So
then
you
we'll
get an
leave it.
exception if it's open. You get an invalid operation exception, pin number whatever is already open. So you can only open it once.
All on the controller.
On the controller, yes. Driver is different, but it's not exposed.
Does it have to be like this?
It does not necessarily. It does not need to be like that.
Because I
No,
mean,
I-
honestly, I think from my point of view, if you basically just say all pins are owned by the controller, they all logically exist, and like calling open multiple times is effectively the same thing as opening it once and then calling set pin mode, then I think your model makes sense, because then you basically just say the pins are owned by the controller, right? You just get them as they are, and they always logically exist, right? Whether it's just lazily initialized effectively. And then, yeah, if you want to get rid of the pins, you just close the controller, right? I think that makes a lot more sense to me than saying you have these factories that you then never basically dispose, because you always dispose the owner for that.
We can adjust the controller to if it's open, just pass the same instance of the GPIO pin, and voila. It's nothing complicated, and I think makes sense in this case. You might.
Yeah, I just remember like the thing that we have where we do as an OAuth is the closing. So if you try to close a pin, that's already closed.
Yeah, because if it is the model that Open's going to throw the second time, then that means that APIs that you're only putting on the pin, like toggle, that those would only be available to the original opener, which means it's only available again if somebody calls close, which means that now close is actually required, so now you need to be disposable. So if you remove your throw from open, then you don't need to be disposable.
We have a throw on close as well if it's closed already, so we may keep that one. But the open one, yeah, okay, got it. Yeah, we can make this adjustment. I think it's.
Is there actually ever a reason then to call close?
Yeah. Yes. In the rare case, you want to change the type of the pin completely. If you want to switch from a GPIO pin to use the same pin for I2C, for instance, or SPI.
Essentially, changing the protocol that pin is using to communicate.
Yeah.
That needs a closed pin because it basically disables the pin from GPIO mode.
But it's quite rare, and most of the switches are between, for example, normal GPIO to PWM, because that's something critical. Think of a LED that you will switch on for some time at the beginning, and then you want just to blink it for some reasons, given the fact that with PWM you can have like 100% or 0% as well, so you can have like full on or full close. But imagine that you're using this pin as well with a button, for example, to reset something or something like that, then you will most likely do that. But those are scenarios which are not very, very often, and people will call that in hardware like a bad design. One pin, one function makes things easier, right? And then having something shared. But sometimes on constraints controller, you want to optimize a little bit, so you can take advantage of having an input button with an output PWM or equivalent sometimes to just gain a pin. That's what you can have. Okay.
Most of the time it's done to set an initial state to the pin. You want the pin initially before opening a peripheral is either high or low, and you want to see that in order to continue the conversation.
That does happen sometimes.
Yeah, I feel like long ago a project I was working on, I needed to use a pin in GPIO mode during a startup sequence and then hand it over to the UART. And then the answer in the middle of the project was buy a bigger package, because I got tired of toggling the pin mode.
Yeah, see.
So one quick thing. So we've had this great discussion about who should be opening and closing the pins. But are there any thoughts and or concerns on the fact that we are on the Uber thing, that we're actually introducing a second way of doing things, and we are introducing a new object where because the initial concerns are still there, right? So there's still this ownership where you can dispose a controller, but the pin can be somewhere else and have a reference to the controller. So you could still have all of those things. Are there any concerns regarding that?
I know of one place where we've done projected view into a disposable thing, and that's cancellation token and cancellation token source. I don't think the token throws disposed exceptions if the source is disposed, but we've probably done it in other places.
It used to in some circumstances, and we determined that was a really bad thing, and so we retconned it in that was .NET 4.0 and in .NET Framework 4.0 and in .NET Framework 4.5, we basically removed all of those disposed checks from the token, or almost all of them at least.
Right, but I mean that one's even different because you can only ask, have I been canceled? I think if it could go back and fire the cancel, then now you would have the okay, well, I'm sorry, that guy's gone away. This doesn't make sense anymore. So
I wouldn't say we have plenty of examples where if you have any sort of object model, right, that depends on a file that is lazy initialized, right? Once you close the file, the thing auto throw, right? So I think it's a model that just inherently exists in anything that is more complicated than just as one type for everything, right? I mean, to your Uber point about two ways of doing things, I think it depends. I think like we have examples in the BCL where you can do the same thing in different ways. I mean, the canonical example is file.io, right? We have static methods on file, but we also have constructors in various places. And I mean, usually there's a reason why we have multiple ways of doing things. We don't just have them because we couldn't agree on a particular style. It's usually things like usability or discoverability or just scenarios where it's just, oh, if you use the constructor, you don't get type inference, but if you use an extension method or a static method, you get type inference, right? There's like these kind of things, but I think I can think of various cases where you have multiple ways of doing things, and I think that's not necessarily bad. Like as long as you have a reason for it and there's like real gains, I think I'm fine with saying, yeah, you can either call the methods on GPIO controller or you get back a pin and then call instance methods on that. Right. The only thing to keep in mind is that if you go down that path, like every time you add another way of doing things, you ought to add them in multiple places potentially, right? If you don't have a clear separation of like, oh yeah, simple scenarios are on the controller and then advanced things require the pin or something, right? That's up to you, I guess. But I would not necessarily just push back on because you have two ways of doing things now.
Yeah, and so it does seem like toggle is new. And I'm actually curious as how toggle is.
Yeah, what does it do?
If it's supposed to be able to be accelerated in a single instruction where you don't even know what the current value was,
So
it seems like the controller
So-
needs that function too.
No, well, yes, we can add that one to the controller as well. The key point here is that if it just change the value to the opposite one, and in some driver you have that at the native level, at the hardware level. If you go for MCUs, they all have that, and it's one operation. So you just say toggle and just it change from high to low. You don't need to read the value. It's a no-brainer. Think about blinking a LED, for example. You do a toggle and a thread sleep at some point in an infinite loop, and you never need to know what is the state to be able to change the state. That's done at the lower level.
When you say it toggles, like, does it mean if I initialize the pin to value 5, the new value is 255 minus 5?
It's not a value. So the output pins are just high or low. So
Yes.
it's on or off. Like think of it as a LED, an LED. So it's either on or off. Toggle will turn. So what Laurent is saying is like some drivers do have the toggle functionality themselves. Where you just call toggle, you don't have to keep state on your logic because it just handles the state. There are some other drivers that don't have this functionality built in. So you do have inside of your implementation, we will have to keep a state in there that says, oh, this is the current state. So each time that somebody calls toggle, we'll have to flip that.
Or you read,
not
read and write. Like the classical way is to read and write. Like if you know, usually you know that on the hardware side you have like a toggle or not, because like you want to make that fast. So you just call it. If you don't have it, then you usually read write or you keep the state. The thing is that because you have multiple ways and you can, but it's not very safe. So most people are not doing it anyway. To multi-thread or whatever, changing the pin of values in parallel. Usually you keep the value and then you use just the write and you write the opposite version and that's it.
So it means that toggle only makes sense for certain kinds of pin modes? Does that
It makes sense only when you write. So when you are in output, it doesn't mean it's useless when you are in input. Like writing in input is useless as well, right?
Right.
But it also doesn't make sense if you're in PWM.
If you're in sorry?
PWM?
Yeah, correct. But the PWM one is not here. That's not
so
the
this
PWM,
is specifically GPIO. We have different classes for different protocols.
Okay.
So everything in here is specifically to GPIO.
So
to
everything
the
is just high or
on-off.
low.
Yeah,
Yes.
exactly. Here it's high or low.
Yeah.
That API, by the way, doesn't have to. Oh, sorry, Rafa. I was just gonna say, like that API it doesn't have to be present in this proposal. Like if it's controversial or for whatever reason we're not sure, like that one, it's okay. If we don't need it for the main scenario that we talked about earlier.
I think it's a fine API. I was just not sure what it does. Because I mean, it seems like you have to read and write with a pin value, so I don't know exactly what it means to toggle an arbitrary value.
And do the hardware accelerated toggles, do those instructions return the state that it's in after the toggle, or is it
No.
actually a void operation? Okay.
No, it's just a void operation when you're on the hardware
Okay,
side.
just making sure.
Sorry, Rafa. Go ahead.
Well, sorry. The other concern is whether the open pin can return the pin itself or should be void. And the 2 points here is that the open pin, if open pin returns something, it could break the binary compatibility. And I would really love to see the open pin returning the pin, because it's, I mean, the best developer experience here. And I would like to know from you whether we can avoid the binary breaking change, if it's possible. But tendentially, I would love to see the open pin returning the pin.
I mean, you can avoid it, obviously, right? You can just say we have a different API like get pin, for example, right? That just gives you back the pin, and then you just leave open pin the way it works today, right? But then, as you said, the downside is that people have to call a different API now. They have to know that there's now 2 ways of doing things, and that might not be what you want. I mean, it kind of depends on what kind of breaking change policy you want to have. I mean, we generally don't do breaking changes in low libraries, because when you have a library ecosystem, it means now you can say, like in this case, it only breaks source compat. It doesn't break it doesn't break source compat, but it does break binary compat, which, if you think of a library ecosystem, breaking binary compat is very, very bad, because now whatever NuGet packages exist that plug into your stuff, none of them will work, right? Because they all now throw like, member not found, basically, right? So that's kind of the thing you have to consider. Is like, you can say, oh, we optimize for user experience and we're okay with breaking everybody who were compiled against this thing, right? But that's fundamentally the trade-off you have.
Right. For that, just to add in there, like this library system device GPIO is supposed to be like under the same support level as any of like core effect well-done runtime libraries. The one thing to consider, and the reason why I think we're okay with taking this breaking change, is that so IoT ships kind of like 2 libraries. It ships the GPIO system device GPIO library, which has like all of the protocols. So it knows how to do GPIO, PWM, I2C, SPI, and then it ships also a library above it, which actually contains the device abstraction. So like, let's say that you have a LED display SD3445, right? So we want most of the people out there in the world, they depend on that higher level library. And that higher level library is the one that's actually calling into the lower level library that actually does the GPIO and all that. So what I'm saying is, the reason why we're kind of okay with making, even though the support level is supposed to be the same as .NET Runtime libraries, the reason why we're kind of okay with making these sorts of breaking changes, it's because the main consumer of this NuGet package is on the same repository. And we've validated this. Like, we've analyzed NuGet packages in the ecosystem, and pretty much everybody depends on the higher level one, not the lower level one. So that's why we're
people
kind of
upgrade
okay.
them in sync, then it's fine.
Yeah, they actually don't depend on system device GPIO directly. It's just a transitive dependency that they get.
Right.
There's the other elements that we've been doing that in the past, when we had changes from major version, and we never really had anyone complaining neither, honestly. I think most people, especially in the embedded world, they are not upgrading and NuGet just like that. So usually we build, you even go for the source and we remove what you don't need. And that's usually how it works, right? So I don't think neither it's a big problem, especially if we do that then for the V3. So it's for a major version as well, not on the way.
Yeah, because with your description, I was actually getting more nervous of like, oh, people are depending on this, LED controller, and it's like, well, great, that means that there's a break in the continuity. But if it actually comes from the same place, then
yeah, it's the same place. Yeah, we keep both in sync somehow.
I mean, you're the expert, so like, I mean, usually for breaking changes, there's some very easy places where we can just say absolutely not, because we know it's super impactful. But this is an area where you are the experts. You know what the impact is.
Yeah, for this we're okay with the breaking change. I don't know if Rafa was asking the question to you.
I mean, that was one of the discussions in the comments of the proposal. And I'm definitely favoring the breaking changes in this case because the developer experience is I mean, definitely the best possible in this case. So I would prefer that.
So I guess then the only open question now is, so we're okay with taking GPIO pin, we're okay with breaking API. We're just discussing whether or not, like how the lifetime of GPIO pin should be managed, like whether or not it should be disposable or have close or.
Yeah, I had one more question. Like you have this get pin mode and set pin mode. Are these super expensive calls? Like why isn't that just a property?
It
Because-
depends on the underlying driver, but it could be. Could be a
Yeah,
problem.
usually, it's a hardware access that could potentially be expensive, and from past experience, having expensive setters is not really nice and sometimes kills the debugger and stuff like that. So
There is one specific case when you are accessing an external extender, and if you are talking using an I2C bus, for example, and the bus is broken, you can have timeouts. And so this, in very bad cases, it can be a very expensive operation.
Yeah, and the other reason is that we want to avoid having exceptions thrown in those properties if we make it property. So that's the key reason why we have functions there as well.
I was gonna say, it sounds like there's also a case where it'll, because of device chaining, that it will throw something other than an object dispose exception. So
Oh yeah.
yeah, I can throw anything. Can
can
timeout
throw
exception, can
anything.
throw not supported exception or whatever. Yeah.
Oh yeah. No, it's so. Yeah, in this case, I mean, I love properties, but in this case, I would keep the functions like that. We have the same function. I mean, with the pin, obviously on the controller, you don't need a pin, but it's a fair question. But yeah, I'll keep the function.
I was mostly asking, did you just keep them because they happen to be methods on the controller, or is there a reason, right?
Yeah.
But like,
No,
it sounds like there's a reason.
They are methods on the controller. On the controller, obviously, you have the pin number. Okay, but because they can throw and they can be, I mean, many things can happen. It's better to have functions than properties because, if I understood correctly, it's better if properties are not throwing, right? So, and not too long in execution and things like that.
okay, and it looks like this value changed is probably implemented in terms of register callback for pin value changed event.
Exactly.
Yep.
So the controller was more of a C-like API. Now we can actually do events. That's the main change. Like, in terms of like the controller, it's just toggle, which is a brand new API, which we can of course consider adding as well in the controller, and then the event. Now we have an actual event. Before it used to be this subscription thing, API in the controller.
So yeah, the only thing that I was thinking is like reading the source code, further down where we had this my GPIO controller thingy, where you have basically open pin with the new one. I was just thinking like if you think people are doing this, then that seems problematic because they're effectively breaking polymorphism, right? Because if they actually downcast to GPIO control and then call open pin, they get the wrong behavior probably, right? So but I guess that's just the sample code is buggy because they could have just easily overridden open pin core and then do the correct thing, right?
This part, like the top part, is what you will have to do today without the GPIO pin.
Right. Like that's the other thing. Like, so if you expect people not to do this anymore, I think that's also fine. But
oh yeah, we don't expect people to do that. We expect people to do just what is after. So if you scroll back a little bit, we just expect those few lines and that's it. Or something equivalent. Again, it's very simplified, but it really simplified the life when you have rather than taking now a device with a GPIO controller and a list of pins. Here you just give a list of GPIO pins and you're good to go.
One last point I would quickly like to discuss is whether this should be whether this new class should be extensible or not.
Oh, we talked about this, Patrick. Sorry, with Laurent earlier today. We said that for now we're gonna keep it sealed. First off, because we always want to keep stuff sealed unless you have like a real scenario where you want to unseal stuff, where you want to extend stuff. Plus, if there's an actual scenario, there are extra APIs that we need to add into the GPIO driver in order to support it. And since we weren't ready for that, we just decided to mark it as sealed. And I know that Jeremy would have asked the question if we wouldn't mark it as sealed.
Well, to be fair, not that I'm saying that which side I agree with. The guidelines actually say you have to have a reason to put the word sealed. The guidelines say you are not sealed unless you have a reason to be. Steve will immediately say he hates that guideline and wishes that I would change it, but I am not man enough to argue with Anders, and especially since Anders won't answer any of my emails. So, yeah, but...
Yeah, I think, honestly, like, in my experience with this current API review board, is like, pretty much everybody hates the guideline. I think there is I mean, I know why the guideline exists, and abstractly, like, it makes sense, but, like, I think it falls apart very quickly. I mean, the sample code that we just looked at is a prime example, right? If somebody just defines new over non-virtual method, I mean, it doesn't really work, right? It gives you the illusion that it works, but then as soon as somebody downcasts, like, everything falls apart, right? So I think the only reason why you may want to think about GPI open as an extensible thing is because GPI controller itself is extensible, right? So you have all these virtuals like open pin core, right? Closed pin core, right? So it seems if somebody wants to actually extend GPIO controller, can they actually do that if GPIO pin is sealed? Like, or do they need something that is virtual to actually get the correct behavior, right? If you think that that's not necessary, then that's fine. But I think, in generally speaking, when the core type is already extensible and has polymorphism, then you want to think about what that means for the other type, I guess.
My assumption, looking at the API that this has compared to what the controller has, is it's just, like get pin mode is just call _controller dot get pin mode pin number.
Right.
That this just knows who's my controller and what number am I.
Well, yes and no. Yes and no, because it doesn't call the controller, it calls the driver directly.
Fair.
Well, but the driver, the controller calls
the controller will call the driver, the GPIO pin will call the driver as well.
Fair enough. I guess because open pin you've already called. I was guessing that one was at least virtual, but it looked like read and write on the controller were also virtual. So you may end up with some. I expected it would call my override method, and it didn't, and so you get to deal with that. But yeah.
Yeah, well, I mean, we'll have to check whether using the driver everywhere is possible, or whether there are scenarios where we need to use the controller for some security checks or the inheritance scenario. I guess the implementation will have to verify whether it eventually needs both in the implementation.
Right. Well, I'm just looking, like your controller, you have public virtual pin value read. So if someone wrote a custom controller and overrode read, they might be surprised that this read skipped their override and went to their driver field.
That's kind of my question. Like, I mean, it's fine to say they call the driver, but like, there's a reason why the controller itself was polymorphic, right? So what's the scenario where you would do that rather than just making, inheriting from the driver, right? Because those are the scenarios that probably wouldn't work very well if GPIO pin itself is fully sealed and bypasses the controller entirely.
The main reason you would want to call directly into the driver is performance.
Yeah. The controller does kind of checks, like whenever you're trying to write to a pin, the controller makes some sanity checks of like, is the pin actually open and things like that. So the idea of like calling directly the driver is to avoid that. Since we already have a pin object, we know that the pin exists and it was opened at some point.
At some point, you don't know that it's currently open.
No,
that's true.
That's correct. That's true. That's one of the risks. But the driver, you'll get an exception anyway, at some point, because the driver will not like it at some point. So you may not get the same exception that the pin is not open. like an event operation, you'll just get something else. Again, you may get a lot of different exceptions, even if something is open properly, and even if everything is correct with timeout, etc. Many things can happen in there.
Yeah, but we'll have to. I think, Laurent, we have to check on this because it is risky to directly call into the driver.
Yeah.
Particularly because the GPIO pin can survive the controller.
I think you want to basically ask the question, like, what is the reason that you would derive from the driver? What's the reason to derive from the controller, right? And how do these things interplay with this GPIO pin object now, right? So it's possible to say like the GPIO pin is completely sealed because, the implementation calls already to virtual methods that you were supposedly modifying anyway. So like everything is fine. But then it does seem a bit weird to go from the controller straight to the driver and then bypassing whatever polymorphism you had in the controller, right? So like that's kind of the thing you need to think through.
The main reason why we decided to make some changes in the controller was to be able to write those extenders, right? Some of the extenders which are usually using other drivers, existing drivers from the real stuff.
So how's
something totally different as well?
With your breaking change, you've shown you're breaking open pin, but wasn't there open pin core or something that Emo referred to?
Open pin core is protected.
It's a protected one.
It's the virtual one that's being overwritten by derived controllers, but these ones are not virtual. I think.
Right. So this is you have this example here where it's like, well, you use new open pin and new write, but this could have been override open pin core and override write. And if these methods in the controller are changing the pin number, doing this virtual redirection of a pin number, what number of pin does this guy think he is?
Whatever the underlying driver.
Whatever you. So in this example, the example you've shown, it's not about GPIO pin. Like you should not do that because you don't have any interest to do that anymore.
Yeah, but if we were to do the same with pins, we could do that, right?
Yeah,
but
you
then
can. You could do that, but then you will have a list of pins. You will not have to override the controller at ***. It will make your life much simpler.
True, probably. Yeah, you
will not have to do the rest. Like you will just directly use the GPIO pin and that's it. You just open the GPIO pin. You have your list of GPIO pin. You make a matching on the pin and the driver, and that's about it. It will make your life much easier. That's the reason we are doing that.
But you could still do this. You could still create the GPIO controller and containing just a list of pins, and then that list would of course contain give the pin number. It's then just an arbitrary number.
And you will not use the GPIO pin, and that's fine. I mean, no worry. So both cases will still work. It's no problem. Just like with the GPIO pin, makes your life much easier.
Right, but going back to the the projected view thing and whether you're connected to the controller or the driver, if the driver can outlive the controller, so you open a controller, you put some pins in a mode, you've disposed the controller, and then you open a new controller over the same driver.
That won't work.
If you're now pointing through to the same driver, it's weird that this pin object would start working again, because the thing it was created off of was the controller.
That should not work, because if you dispose the controller, the driver is gone as well.
It's gone as well, yes.
Yeah, okay. We would have to check whether it properly supports, whether it properly throws object disposed exception in this case. Because if it's still referenced by the pin, it's the instance is alive, but it's disposed. So
I'm checking quickly how the dispose is, but you'll get an exception at some point.
Okay,
right?
If the driver can't outlive the controller, then
it's not something you can leave alone. I mean, you have to pass it, and you just can't use it.
I guess you could make a custom driver
set the driver
skips the disposed.
to null. we set to the driver to null when we dispose the controller. So the driver does not exist anymore. So if you try to use the pin,
if
you get an
the
exception.
GPIO pin's field is the driver and not the controller, then it still knows about the driver, and there's nothing you can do to stop it. So the driver instance would have been disposed, and then do whatever it does when you dispose it, which a custom implementation could, of course, do nothing. But so I'm just like so you'll have to work out. I would think, looking at the model, that if I overrode write on the controller, since the controller is what gives back the pin, I would expect you're going to call my override method. Whether it's that I'm in that controller object, I've added debugging to just track down when all this is happening or whatever. I think I would be really surprised if it was bypassing the controller. Granted, you can say in documentation that that's what it does, and that you shouldn't do any of the logical pin remapping that you did here in the my GPIO controller class to pretend that you had more pins than you do by doing the off. Like, you can write all this stuff down, and then point somebody back to, well, we said right here, the way you're trying to use our class is not what we want you to do. But I think I would be surprised if it's bypassing any of my custom logic.
We can still do it if it's necessary, because we can, at the open pin, we can take let's say a strategy and decide whether to call the controller one or go straight to the driver. We can know it. No, it's possible to know if the implementation is the default one or not. And in this case, we can change the strategy depending on that. And if you want us to call the implementation that you overrode, that's fine.
I mean, yeah, if GPI controller's type is, if it hasn't been extended, if it's literally GPIO controller, then you can certainly be like, great, do a direct driver binding because we know what all the checks are going to be. But yes, the worst part of an inheritable type is when people inherit it. So
We're not going to inherit from list T.
No. Yeah, I mean, another question to ask is like, was it a mistake to make GPIO controller polymorphic, right? That's another thing. If you say like the primary reason was to do the thing that we now figured out is too complicated, and we would rather people to just take a list of GPIO pins. Since you're making a breaking change, I think it's worthwhile maybe revisiting that as well, right?
We are using that internally already.
We are using that for some of the extenders. I mean, like for example, we have extender with I2C that brings GPIOs, etc. So you need something like that in order to work more than just a driver, I think. But we have spare. We can check. I don't know what we have today in there.
The board binding depends heavily on it.
Yeah. But yes, correct.
That's what the use case why we opened it up.
Yeah. I'll not close it. I would check what happens in the different scenarios that you both pointed out. I think that's what we have to do, and then document. And if there are any change we can make to either the driver or the GPIO, which are non-breaking, but can simplify the life or double check something, we should do it. Definitely, like double opening and things like that will give you back the GPIO pin without complaining. I think those ones are very valid. But we don't necessarily need to seal it again. Don't see any reason why. And again, because the GPIO pin is using the driver directly, you'll always get the best out of it in terms of performance. That as well what we want at the end.
Yeah. Yes. Can you have put these things together and make an estimate on that, Laura?
I can try to put an estimate on all of that. Bullet point, I took some notes. Give me a few days for that.
Yeah, sure.
Yeah, we don't have to bring this back to API review. Like we wanted the expert's opinion for this. I think we've got like very good feedback. And yeah, in terms of the notes, Jeremy's a very good note taker, as you can see. So he has great summary for us. And I think like answering to Emil's question of like, should we wrap GPIO? I think we have enough to work on now. So it's fine if we, continue this between us. I think it's fine.
Okay, so yeah, this is as was written because all these names seem to be based on the ones on the controller, so they all seem fine. The only change that I added was toggle with pin number on the controller, and I had assumed it would be toggle pin, but then I looked and write is called write instead of write pin, etc. So toggle pin, whatever you think's the right answer.
Sounds good.
Sounds very good. Thank you.
So does anybody have anything else on this one, or do we call it approved?
Yeah, it sounds good to me. Approved with the comments. Yeah.
Oh yeah. Shoink.
I guess you do the copy paste right away. Perfect.
Yeah.
Good.
Awesome. Thank you so much, folks. I have a call, but thanks, Jeremy. Thanks, Emil, and thanks everybody else.
Thank you, everyone.
Gracias y de nada.
Have a great rest of the discussion. Bye. Bye.
Bye-bye.
Thanks for joining us.
Bonjour, merci.
Merci.
Butchering French and German today.
Yeah, I can murder all sorts of languages.
All right, so I can speak to this one, and Martin's here as well. We have a variety of dictionary classes today in .NET, but they're all pretty much focused on mutation, including our immutable collections, which are optimized not for reading, but for, while they can't themselves change, the data structures used internally are optimized for creating a new variant of that thing while reusing as much of the memory from the original thing as possible, with the exception of a mutable array, which is just a struct that wraps an array. But in a lot of scenarios and services, you have data that once it's kind of baked, it never changes. Maybe or rarely changes. Maybe you load it once at startup and it exists for the rest of the process, or maybe you even hard-coded it into your source, or maybe it came from configuration file and it only changes when someone actually modifies the config file and causes it to be reloaded, once every 3 days or something. And in these situations, you really want to optimize for reading. You want to optimize for the throughput of lookups and enumeration and so on. And we lack a set of collection types optimized for that. This is primarily about dictionary and sets. We have arrays. We have a mutable array that largely suffices for that scenario. So this issue basically proposes 3 things. 2 types, one a frozen dictionary and one a frozen set, and then a set of extension methods for creating them from arbitrary data sources. These types are fairly minimal. They basically provide the surface area you'd expect, implementing iDictionary, iRead-only dictionary, and providing the various lookup methods you'd expect, contains t, try, get value, and indexer, and so on. Because they are immutable, some of the concerns we've had in the past around exposing refs into things like dictionary don't really apply here. So, for example, we exposed the ability to look up a ref from a dictionary, but we had to shove it onto collections Marshall because if the dictionary was growing, that ref becomes invalidated. That's not an issue here. So the methods here return ref into the dictionary, for example. The keys and values are exposed directly as immutable arrays, so you don't have to have a separate keys collection that wraps the underlying dictionary. Basically, you just get the immutable array into the keys or the immutable array into the values. And all these things have efficient enumerators. Now, the types themselves are abstract because depending on the kinds of data that you're feeding into that, there are different implementation strategies that can lead to optimal lookups. And we can provide any number of distinct algorithms and data structures for varying inputs, for varying sizes of inputs, for various different kinds of types, whether you're dealing with strings and ordinal or ordinally nor cache, or you're dealing with integers or value types or whatever. We can have, for the most impactful scenarios, we can have these factories produce customized implementations optimized for those inputs, so that you basically just say to frozen dictionary or to frozen set, and you get back your frozen dictionary, frozen set, and we've done our best to optimize it for lookups for that data moving forward. And that is essentially the API. There are a variety of decisions that I made. Martin created an initial prototype for this. I then sort of tweaked it based on what I thought made sense for adding into .NET 8. A variety of things are worth discussing. I thought this made the most sense to live in both system.collections.immutable DLL, as well as the namespace, since these are immutable collections. That also has the added benefit of, since we already ship this as a NuGet package down level, all of these will also be available for consumers, and Martin in particular cares about that. I implemented the relevant non-generic interfaces here. So iDictionary for frozen dictionary and iCollection for frozen set, because dictionary does so and sorted set does so. Interestingly, hash set doesn't implement iCollection, but it seemed like if our goal is to make these as plug and play into existing use cases as possible, we want to implement those interfaces. I did not implement the iMutable dictionary and iMutable set interfaces, because those, again, are sort of largely focused on mutation, ironically. And we just have a whole nother set of methods that would be throwing not supported exception. And those interfaces really aren't used anywhere.
Well, the alternative is actually to implement them just extremely slowly.
Yeah, I mean, we could create, or we have a few options. We could implement them to throw. We could implement them to actually create the other immutable types, or we could implement them to create these frozen types. And my guess is we'd actually do the middle one, but I don't see a use case for it. So I haven't included that here.
So given that we have immutable hash set and immutable dictionary, how do frozen foo and immutable foo differ, relate, convey themselves to users, etc.?
All of those immutable dictionary, immutable types, they're implemented with the idea that you're going to be mutating them somewhat frequently. And so you don't mutate them directly, but you call an add method on them, and they produce a new immutable dictionary or a new immutable hash map that shares as much of the memory as possible from the original instance. So the data structures are typically various forms of trees, red-black trees, B+ trees, whatever, that are fairly inefficient for lookups. They're like order log n to do lookups. Go ahead, Martin.
So this shifts the computation to creation time. So that's one thing you forgot to mention. Creating these collections takes a long time because it's optimizing the layout, and so it's shifting the computation to creation time, because we expect it happens very rarely, to speed up the read time. The immutable collections kind of amortize the cost of these mutations. You can do mutations all the time, but the mutations are expensive, the reads are expensive, relatively speaking, so it's a different use case.
So like ironically, reading from an immutable dictionary is slower than reading from a dictionary.
Yeah.
Fair enough.
I mean, like when we designed the types, like unfortunately we went with the terminology immutable. Like at the time we knew that the thing we're building is really persistent. Like that's the name in the industry, to basically like have this memory sharing model effectively, where you try to reuse as much as possible. But we know that when we worked with the Roslyn team, like the performance of immutable list, for example, was not good enough. So that's why they basically pushed, at that point, they called it read-only array that we then renamed to basically immutable array, which I think if we could go back, we would now call frozen array, because that's really the thing that we want, right? And we don't really have an equivalent for this for dictionary, right? Immutable dictionary, as we said, is very slow. So the end result is that Roslyn has their own immutable dictionary copy, which I think behaves more like this frozen dictionary here, where I think it might just wrap a dictionary because the performance of dictionary is good enough for them, but it definitely does not use the tree data structure. So I think from a scenario standpoint, they make perfect sense for me. I'm actually glad that we would have the types now. I even like the names. I'm not sure I like the namespace, but I think it has pros and cons. So I think I'm open to that.
Yeah, we could create a system.collections.frozen with these three types. I still think it would make sense to live in system collections immutable DLL.
Yeah,
sure. Yeah, mine is really the everything in the system collections immutable namespace has immutable in it, and there's in that same namespace, if we do it as proposed, we would have an immutable dictionary and a frozen dictionary. And I think if you're looking at it, you're like, these sound like they're the same thing. I don't know how to pick between them. And if what we say is, well, look at where we have system collections, specialized and system collections generic, and like one of them maybe you don't want to use anymore, and now we have system collections frozen, and if something's in frozen, that's probably what you want over immutable. Because
that's
they have
fine.
different design
we can go
rules.
with a different namespace. We're going to have the same issue you just talked about, when someone dots off system.collections and sees both immutable and frozen.
Right, but right now they have immutable, generic, and specialized, and immutable is specialized, and most of the generics are specialized, but we have three different namespaces there, and they do different things.
Yeah, like I said, I don't have a strong opinion on the namespace.
Do we think we will grow this list? Would we eventually have something like frozen list?
I don't know what a frozen list would be. That sounds like an immutable array.
Also, in the original implementation of this, I did have a frozen list, and it is just like an immutable array. I created it strictly for symmetry.
Right.
Which might have value here as well. But if you're saying the immutable things are kind of slow, don't use them, except for immutable array.
Yeah, but that is we do use immutable array in places where we want an efficient struct-based array wrapper. Right? Like that is the exception. It already is the case.
Yeah, I think that ship has kind of sailed. On the other hand, like we had this discussion before, right? Should we type forward immutable array further down so we can use it in more places, right? So if we would go with something like frozen list or frozen array or something like this, we could do this probably with fewer moving pieces, because immutable array basically depends on all the mutable interfaces. So if you want to move this one, you have to move a whole lot of stuff, right? So that would be maybe the only advantage, in which case maybe these frozen collections would live lower than immutable collections would live in the, which today lives in a separate assembly that lives fairly high level. That would be the only reason why I think it might be worthwhile having it. I wouldn't just create the type out of, or the naming aligns nicer or something. I wouldn't do that.
Yeah, I mean I think it's if we decided we really needed it in system, my guess is Steve would just copy the code, and we'd have the non-public frozen dictionary that lives on the inside, and then we'd have the public frozen dictionary that lives at the higher level, especially if there's a need for the Net Standard 2 implementation, because we'd have to solve that problem with some new package. So
another question I have is on the frozen set. My recollection is that some of these methods that we have today on hash set and sorted set are actually modifying when you do these proper subset things, like they kind of mark things as visited or something like this.
So not in the implementation of hash set, for example. It's on hash set, like these things are non-mutating.
Okay. And then is this frozen set, like, is it a hash set or is it a sorted set? Like, what's the logical model behind it?
It's not sorted.
Should we then call it frozen hash set, maybe? So that if we ever wanted a sorted set, we don't stand on the name?
I think our other set is called sorted set, literally. And so we'd have frozen sorted set.
Right, but my point is we don't have a set type. We have a hash set and we have a sorted set. So maybe we should have a frozen hash
You're saying
set.
if we ever wanted a frozen sorted set, we would need this to be called frozen hash set.
But the interface is called iSet.
Yeah, I was gonna, like, I don't know, like, hash set is one of those, it's leaking some version of its implementation into its name.
Yeah.
I don't think anybody even knows or really cares what the hash part of hash set does. They're just like, oh, sorted set isn't actually a set, it's a dictionary, so hash set's the set I want. And that's the end of the thinking. So I don't think there'd be a problem if it was frozen set and frozen sorted set.
I guess I buy that. I mean, it's the same with dictionary, right? We have sorted dictionary and dictionary. We don't have hash dictionary, right? So
right.
I guess probably for hash set, they just wanted to avoid the super short name.
It may have been avoiding a short name. It may have been that
doing like Java
had some other thoughts of like there are maybe 4 set types we're going to add, and we don't know which one would be set. So and then we only added the one. But
sure. Martin, you were saying something?
I was just saying it's doing like Java. This was 20 years old, right? This hash set thing, so.
I think hash set is actually not that old. I think it came in 3.0, I think, which would be 2008-ish, I think. But
I thought it came in 2.
Was it?
Yeah, it came in with the generics.
But I think to me, it's like just we can. I mean, I think the argument about we can always have a frozen sorted set if we wanted to works. I think.
One other thought that just occurred to me as I was just looking at, taking a step back and looking at the APIs. The abstractness here is an implementation detail, right? Unfortunately, there's a lot of abstract on the screen, and I just realized that we don't actually. The only abstract we actually need on the screen is on the class. Everything else can be done via non-abstract members that are one-liners that wrap abstract members, and there should be 0 perf impact.
Right, so is proper subset of call
all those, yeah.
protected virtual.
Exactly.
And if you go private protected virtual, then it doesn't even show up in the ref set.
Right. Yeah, none of the implementation tools show up in the ref set except for the abstract on the class. I think we should do that.
That sounds fine. So right now the only way to construct these is extension methods. Do we feel that that's a good approach, or would it make sense to have frozen set non-generic dot
That's
create?
One of the open questions I had in my open questions list below. The option is basically to add frozen set and frozen dictionary non-generic. We still, I think, so, and we could choose to either have extension methods or not.
Right now, it's very convenient. You just take whatever collection and you say .freeze or .to frozen dictionary, and you got the thing.
Well, so I was recently doing some work with ML.net, and they do a lot of stuff with extension methods, and I moved to a new project and I was missing a package, and because I was just calling extension methods, literally nothing can help tell me what package I'm missing. It's an extension method's missing. Sorry. If you have a static method call, then the go search for things pattern can be like, oh, I think you wanted this package. So there is a user experience difference when it comes to copy pasting code.
That's fair. That said, if you're using this without storing the results into some kind of field, you're using it wrong. And if you're storing it into some kind of field, you need to name the type. And if you name the type, you need to that is your hook.
I mean, if this is an iDictionary, then you could be saving it as an iDictionary.
That's fair.
I mean, you could, but I mean, if you call something like to frozen dictionary, and if this code doesn't compile, well, you kind of know that wherever frozen dictionary lives is where the extension method is probably going to be as well. So I feel like in this case, it's not that much.
What is it you'd recommend? What is it you would prefer to see instead, Jeremy?
Well, I just think that a more direct model would be the frozen. Add frozen dictionary non-generic and frozen set non-generic, and they have a create or whatever. And in fact, it could be that we just make those static methods, or the extension methods, live on those types, right? You could have frozen dictionary,
right?
To frozen dictionary of, and then somebody could either call it as frozen dictionary dot to frozen dictionary of an existing dictionary, or they could call it as an extension method.
So that is the alternative that I was considering. That is also what the other immutable collections do. Like there's a mutable list that's non-generic with a
also suggest, don't put extension methods in a type that ends in extension. Put them in a type that has purpose. And
so we could do that. It felt wrong to me to have 2 types, each with 1 method rather than 1 with 2. But I'm fine with it. We could split it.
Well, once you have factory methods, it's more members, right?
So I have a question on if frozen is the right term to use here in the name. We actually use the term freeze in several places already, especially in WinForms and WPF. And it's generally used to differentiate a collection or type which can be frozen and unfrozen. So normally it's mutable. You freeze it, it temporarily becomes immutable, and then you can go and unfreeze it later. We even in collections immutable have some internal freeze methods today and use the term freeze and frozen and unfreeze to refer to the same behavior.
I think that's fair. At the same time, I think this is the same concept. There's just no unfreeze.
Right, which is, I think, maybe the problem and something that some people may expect or want of such named types.
Well, they'll be sorely disappointed.
I mean, the question would be like, what's another name? But I mean, you could call it fixed, which wouldn't be terrible, but then fixed has other connotations, right? So I can live with frozen. Originally, I didn't like frozen because I thought there's an unfreeze, but given that they're always frozen, I think the name makes sense. And like you kind of, I think if something is called frozen dictionary, and like I don't think I would expect an unfreeze, to be honest. Like I think at that point it's kind of it is what it is, right? So
because it is frozen, it is not a freezable, which would give it freeze thaw.
You can name it Elsa or Olaf.
What about the case of people may have existing extension methods called freeze, or the internal methods called freeze, which can conflict with the extension methods even though they're internal.
Well, these
are called to frozen dictionary and to frozen set.
Yeah.
Okay.
Yeah.
Okay.
I would also say don't care. Like I mean, if that's the bar, then we can never add anything because you can always make up somebody has an existing extension method with the same name, right?
Right. It wasn't along that. It was along the lines of we have an existing concept of freeze and unfreeze, and so using the terms here may conflict. It's got a higher chance of conflicting with other people's types, and so just a consideration from that aspect.
Sure.
Yeah. Just like I think frozen's not terrible. I just wanted to make sure that the points were raised on, we have tons of results already related to freeze, frozen, etc.
I bet you nobody's using congealed.
Wait, what? I learned a word.
Will.
I learned a word from Portal 2. Vitrified. It's a vitrified collection.
There you go.
Nice. Can we come up
Petrified collection?
Well, because vitrified is that you've sealed it in glass, I think. So you've poured glass around it, and now it can't change anymore.
And petrified is turned to rock.
Yeah. So
rock solid collections. I like it. My only question for the extension methods was, I think the most common way to construct a dictionary is not with the enumerable of key value pair, but more with a selector. Should that exist as well?
Sorry, what was the question again?
So when you call to dictionary today as an extension method, right? I think the most common way to use it is not with an enumerable of key value pair, but rather with a selector where you basically pass in a func of t key and then instance of enumerable of something else.
Oh, we could add that as well if you think it's valuable. I think it's I think a fairly common use for these will be new dictionary populated and then .to frozen collection, and there you actually want it to be enumerable key value.
Right, but now you have to basically go via the intermediary, right? If I give you a to frozen dictionary and I give you a selector func, then you could avoid that, right? You could optimize that away and just straight go to the whatever optimized thing you have.
If you're that depends on what the data source is. Like if you're loading this from a config file, you've got your configuration data. You're not producing the value based on the key.
Are you asking for to use it as an alternative to the link to dictionary method, where it's IEnumerable to dictionary and what makes this the key?
Yeah.
Yeah.
Oh wait, why can't I use the selector to produce an IEnumerable and feed it in here?
Well, because it's
Isn't
not
that what
there,
link's
right?
about, kind of thing?
Well, if you did do the link thing, would you put it in the link extension class?
No, we would just keep it here, but it would just be an extension method over IEnumerable or whatever, right? Similar to this one.
Yeah, it's so.
Yeah, that one.
Here's the enumerable of values, and from the values, what are the keys that I should extract from them?
Yeah, I think the logical. Oh, sorry.
Go ahead.
But like the logical conclusion to doing link methods, right, would be like to have more link methods just support, like produce these directly if you're trying to save the intermediaries.
Right. Well, put this at the top so I remember to delete it.
I mean, there is another issue that's asking for a to dictionary that takes an IEnumerable of key value pair, for what it's worth.
Yeah, I mean, I'm not opposed to having that. I'm just saying, for me, I think I've never went with an IEnumerable of key value pair. I always went with a selector of func, pretty much.
So for what it's worth, in our code base, we have probably a couple hundred uses, and it's always an IEnumerable because it's always coming from config or a static dictionary in the code.
You say it's always an IEnumerable. It's an IEnumerable of key value pair.
Well, because it's usually it comes from a dictionary or a set, a regular dictionary and a set that you initialize, and then you give it to this.
You're right. That is pretty ugly.
Yeah, that's why I don't do that, right? So, but like I think in your world, right? If you, I mean, IEnumerable of key value pair is really an abstract way to say dictionary, right? So if you already start with a dictionary, then this proposed extension methods make sense, right? If you don't have a dictionary, if you have a list of something that you want to turn into a dictionary, then that's usually how I start, because I don't use two frozen dictionary, I use two dictionaries. I don't have one yet, right?
So I think we need the IEnumerable key value pair overload. If we also want to add the rest of the two dictionary overloads, I don't really care. But just adding this one, I don't think you'd want to add both the one that takes the source and has a func to t key, and then also one that additionally has a func to t value. I don't know that they're going to get used, but I don't have any qualms about adding them if you think they're useful.
I mean, they also could be methods on the static type that aren't extension methods. If we think we're going to pollute enumerables too much, we could just say.
Well, I was assuming they would just be overloads of this to frozen dictionary method.
I guess that's fair. Once it's an overload, it's
I
the same
mean,
thing in IntelliSense.
Yeah.
What it's worth,
doesn't matter.
Link also has the toLookup method, which returns what amounts to a different variant of a frozen dictionary. So wouldn't it be the case that we could simply replace the ILOOKUP implementation with whatever we build with this frozen dictionary thing?
They have pretty different. We as an implementation detail maybe, but they have pretty different cost structures.
Yeah, exactly. If you throw a million items to a frozen dictionary, you're going to be sitting there for a minute while the thing initializes.
Yeah. Also, I think iGrouping is multi-value, right? Which you always pay for too. Versus in dictionary is always given one key, you get one value back.
I mean, we still probably, we've got some work to do to work on the performance of this. There's multiple facets to the performance. I think we should work on making construction faster. We can also work on figuring out what are all the other additional things we want to special case from a throughput perspective for lookups. We've got the initial implementation basically ready to go, and we can tweak it over the next months.
But by definition, though, this should not be used for transient things.
Yes.
Which is what link tends to be used a lot for. So I wouldn't put this into link.
Yeah.
That's
in fact,
true.
To the comment earlier about should we push this stuff lower so that we could use it, I'm hesitant to use these at least extensively elsewhere because there is a potentially measurable impact on startup.
Right.
And so I'd want to avoid using them in situations where that could be a problem.
Yeah. But I think, to me, this calls out a standard pattern for long-lived processes like services.
Yes.
I don't care that it takes 10 seconds to start my service if you're going to save me $100,000 a year in COGS because the thing runs faster.
Right.
So there are different trade-offs to be made in an IoT device than in a service, and this is one of those.
Yeah, all my websites are effectively serving out of memory, so I already have places where I use dictionary today, and I just cross my fingers that I don't write to it ever. So I would totally move to these. Yeah.
All right. So before I do the work of copying and editing, do we want all of the link to dictionary overload patterns here?
What are all the ones? The only one I can think of is the one with the selector.
There's one for this. There's one that takes the selector for the key. There's another that also takes the selector for a value.
One takes a comparer, which I guess right now this doesn't have comparers, so we would leave that one out.
It does have compare. It says an optional parameter.
Okay. Oh, yep, right there. Yeah, so a key selector and a value selector. Yeah, so key selector, and that here's how you split the object into a key and a value. So assuming that we do it with defaulted values, it would be adding both. So I guess that's better than adding two things. Seems fine.
My intuition would have been that the most commonly used is the one that only takes the key, but apparently the most commonly used one is the one that takes both key and value.
That's because my guess is it's because you rarely want, unless you're just doing some hacked up thing. The thing that contains the key often is not what you want as the value.
I don't know. I feel like anytime I've used dictionary, that's what I've wanted.
Yeah, that's kind of what I was thinking too. But I mean, to be clear, right? It's like the one that takes both is 36%, and the other one is 11%. So it's still widely used by reasonable standards, right? It's just less.
Like I said, I have no qualms. They're easy to implement. They're
Yeah.
tiny. They're not going to add a whole lot of weight to the DLL. If we want them, that's fine.
I mean, to me, the argument really is that it potentially allows you to avoid intermediary dictionary, right? So if you want to optimize that
From a usability perspective, you mean?
Yeah, from usability perspective, I mean, I would like them, but
I'm missing something. I don't understand. If the API takes an IEnumerable, why can't I just use link to produce an IEnumerable to feed in there? I don't need an original dictionary, right?
no, you don't. But like, I mean, it's just the code that Jeremy had on the screen is like fairly convoluted, right?
To key value pair doesn't have a. I mean, we
right?
could decide as part of this we want to add key value pair dot create.
That already exists.
We already have that,
Okay, so
but recently I think it's
.NET
since
5 or
5.0,
something.
Yeah, .NET 5. No, .NET 2 actually.
So,
Never mind.
but yeah, I mean, this still you have to think about this. Go create a key value pair thing in the middle. So
Yeah.
And this would just be we get to rewrite this line as oh, it's a complete rewrite. So to frozen dictionary of foo to foo.key. Like,
Yeah. To me, that reads easier. Like
or apparently the
Yeah.
if you're Steve.
So are there similar factory methods for regular dictionary?
That's what we were just looking at. That's what Link provides.
Yeah.
Oh, okay.
Like that. This big mess here is I copied it from Link and I'm cleaning it up to look like Frozen Dictionary.
Right.
It's a one-line utility function. Doesn't hurt anything.
Yeah, I mean, all that
I don't have a strong opinion. It's fine
all that
if
the
you want.
other two things would really have to do is write that great, go turn this input into this enumerable of key value pair and go call the other thing. So they're just vanity. By the way, if anyone can explain what signs on beaches in Cannes, France that say no vanity metrics mean, I would really love to know what that sign meant. Moving on.
No vanity metrics?
Yeah, there's a sign. I probably have a picture somewhere, but I don't have it at hand. It had a bunch of like where you get pictures, so they don't have to translate it, and so you get like no. It was a soccer ball with a no through it, and then there was just this last thing, and it was the English words vanity metrics, and it had a circle with a slash over it. And it's like I have no idea
in France
what vanity metrics would mean, and what vanity metrics would mean in France, and why you can't do it on a beach.
So does that mean you can't have people comparing the muscle sizes or these kinds of?
I don't.
Like
the best I could
Venice
come up
Beach?
with is like, don't be recording TikTok or Instagram videos or like don't be doing social media is the best I could come up with. But it baffled me, and I couldn't find anything explaining it on the internet. But as I almost said the phrase. As I said, it's a vanity thing. The vanity metrics popped back in my head. So,
by round trip vanity metrics between English and French to English and Bing, I get vanity measures.
Yeah, that's why I was suggesting you're not allowed to have bodybuilding competitions or something.
I would just put a sign next to it that says all your base belong to us, and then move on with life.
Yeah, but. Okay, so I added the key and element selector overloads.
To remove abstract from everything except from the class definition, the class signature.
Yep.
Can you scroll down? I have some questions, comments at the bottom of my thing. Just want to make sure we talked about them all. Assembly, namespace. Did we decide what we wanted to do there?
So I'm okay with with immutable as the namespace. I just think we need to feel confident that we're okay with introducing a thing not called immutable into that same namespace, and that we can help people understand the difference between an immutable dictionary and a frozen dictionary. If we think it's complicated enough that it warrants a new namespace page to talk about the concept of the frozen types, then we should use a new namespace.
Yeah, it's somewhat asymmetrical. You put them in the same namespace.
Yeah.
If we want to, talk about it as their own dedicated thing and have their own docs page, like Frozen is fine. I don't have a strong opinion.
I mean, I think if we have 4 types, right, that's kind of like the min bar. Like, if it's just 2 types, it seems a bit weird. But now they always have the static types. Maybe that's okay. But it is certainly at the threshold boundary of like, is it worth it? But I think it might actually help to talk about them if they're peers. The fact that one references the other, I think you can kind of hand wave away.
All right, let's go with Frozen.
But that's my other question. Like, are we really sure we want a mutable array there? Like, are we sure we don't want to ever add members to those key collections and value collections? Are we 100% certain that's the outcome?
I don't know what we would want to add there that we wouldn't want to add to a mutable array.
Yeah, I'm just asking because every time we pick one of those core types that are not specific.
There you go. This was a sign on a beach in Cannes, France. No vanity metrics.
It's a very official sign too. I don't know.
Why is it smaller than the other ones?
I don't know.
Because size doesn't matter.
And this QR code did not explain it. So.
That's hilarious.
Yeah, that is.
There's a lot of stuff you can't do there. Damn.
Yeah. No radios. No sports balls. No dogs. No spear fishing. I guess. But yeah, I don't know. It was weird. It haunts me.
So, Emo, do you think we should have a frozen array?
No, I'm not saying frozen array. I'm just saying like all the key collections that we usually have are like specialized, right? They're not like general purpose types, right? And I don't know why we did that, whether it was for performance reasons so we can wrap something, or whether it was for not exposing right members on those. But
yeah, I mean, I think it is. They're optimizing for different things. Like on dictionary, those types wrap the dictionary, and then enumerating them or looking up them has to fish out the data from how the dictionary stores the data. But if you're optimizing for enumeration and lookups and whatnot, you spend a little bit of additional memory to have the extra array.
Gotcha. So you basically just say like it's part of the API contract to say we just have a copy of the keys and a very handy data structure.
We can do, try and do interesting reuse, but yeah.
Yeah.
Like for example, one of the optimizations Martin put in place is if your key is an integer, because of how the underlying hashing works, we can end up reusing that int array used for the hashing rather than having a separate keys int array. But that's just one specialization to save some memory.
Sure.
So, was that keep them in immutable or move them to frozen?
I think move them to frozen.
Okay.
Because we expanded the 3 classes to 4 classes, we crossed the threshold.
Okay.
And maybe we'll add frozen sorted set.
Yeah, there you go.
Worthwhile. So the ref returning one, I'm just reading this, but that seems fine, right? There's no downside.
So there are two issues with the ref returning things. One is, are you returning a reference to something that's transient, which is the case with dictionary, and that's why it's one of the reasons we shoved it off to collections marshal, because it's sort of this unsafe thing. That is not an issue here. The other lesser concern is we on dictionary we also have or in collections marshal we have get value ref or null ref. Like if it doesn't find the thing, you return a null reference. And there's a small concern that's a little difficult to work with. I don't think it's a big deal, but
I tried a variety of signatures for that method. I couldn't come up with something better.
Yeah. The only other thing I could think of was the try get value out span.
Yeah.
But this seemed like a reasonable thing, and for unless you're an advanced user, you're not going to be using this API anyway.
But is there any downside with returning a ref read only T?
No, other than
when it's null.
Other than when it's null. So from the indexer, there's no downside.
So because an immutable array, it's for some reason just T.
And that's because we did that before we had ref returns.
And it will be a breaking change to change it to ref read only now?
Yeah. Binary breaking.
Yeah, I mean.
But like for read only span and read only span, return ref from the indexer.
Right. And presumably that's what an SD array does as well, right? Logically on the indexer.
That's what does, sorry?
The SD array, the thing that doesn't really exist as a type.
Yeah.
Yeah.
So that is one difference between frozen list and immutable array.
Right.
The frozen list I had let you access the items by ref.
Presumably ref read only.
Yeah, ref read only, yeah. Which is what we do here. Yeah. That's fair.
Would it be possible to extend the immutable? No.
Well, immutable array didn't we add like an item ref or something to immutable array? Or we were talking about doing it?
I thought we talked about it, but like looking at the sources, we clearly didn't do that. There's no such thing. I mean, it might be in collection marshal or something, but like it's certainly not on the core type.
Collection marshal can't talk about immutable array. It's too far forward.
Or maybe there's an unsafe type.
No, we did. We added item. There's a public item ref on immutable array.
Where do you see that?
Line 140 of immutable array _ minimal.cs.
Oh, I'm looking at the wrong source code then. I looked at the other one.
Oh, I want immutable array of T. I found the wrong immutable array twice. I'm good at driving today.
Gotcha. Okay. So yeah.
And there's a as span, which also gives you the same effect.
I guess
that also exists on immutable array.
I guess APIs of .NET doesn't understand ref returns. Emo.
Yeah. I mean, clearly it does not. Right? Let me follow back on this one.
Okay.
So that works.
I think we covered everything on the list.
Okay, and Eric had mentioned the to look up / I look up, and then yeah, it does seem that is expected to be a key to a multiple value, so I don't think it applies here. Just wondering.
And it's very different cost structure.
Well, it's because just looking at I look up, where it's I have an indexer and whatever, it's like, well, this could certainly implement that interface, but then I noticed it's supposed to be a
you meant should this be implementing that interface?
Yeah, not taking over the version of the method, but would it make sense for this to be an I lookup or are there any other interfaces that make sense to put here, especially because it's, as far as the BCL is concerned, a high level type, so we have access to
the nice
everything.
thing about this being a class rather than some kind of interface is we can add more interfaces in the future if we want to.
Yeah. Stephen, have you talked to the Roslyn folks about their internal times that they're currently using?
I haven't. I didn't know they had a frozen one. I'll go take a look.
Yeah, they don't have a frozen one, but I think they have some, because immutable dictionary isn't fast enough, and I think they have the same for sets as well.
Oh, I'll go see what they've done. I mean, the moment we add this to system collections immutable, Roslyn will be able to consume it. So
exactly right. So that's the other thing. I mean, because Eric was just asking in chat, like I would not have a separate NuGet package. I would just put it in the immutable one, because it's already net standard 2. It can go anywhere you need it to. So
what's the downside in implementing iLookup?
I think iLookup, given a key, gives you multiple value, gives you an enumerable, I think.
Oh, it does. Oh, that's a different thing.
Yeah.
Okay.
And I think you don't want necessarily to pay that.
OT element. Yeah. Okay. Yeah.
The indexer is a enumerable because it's the type is enumerable over groupings of things. So, which means that then there's the other complicated grouping enumerator. So yeah, it does seem to be a very different beast than a dictionary.
Will the types being in collections immutable negatively impact Roslyn or VS, considering that Roslyn is inserted into VS and they track all the assembly sizes?
Well, that one is, we can look at that once we have it. I have no idea what the overhead is going to be, right? I would generally say if it's in a separate namespace, then at least all the source breaking changes potential is close to 0. But yeah, size, we can look at that, but I don't think we have had problems with that before.
If Roslyn is going to be able to rip out an implementation of theirs and use this, then it should be nearly size neutral.
Yeah.
From the overall compiler suite.
Yeah, that's unfortunately not how RPS works.
Fair enough.
Have we bumped into problems here? We've added a fair amount of stuff to system collections immutable. Has this tripped up in the past?
The system collections immutable and system reflection metadata are both special to Roslyn, and the entire insertion process for them, for both Roslyn and VS, is often painful. It may be that this is a non-concern in this particular scenario. I just think it might be good to confirm with, I think Jared and Fred are the main people, but that may have changed.
I get all that. It's fine to follow up on that. I'm just asking, we've added a ton of surface area to system collections immutable in the last few years. I'm wondering if this has happened, if your concerns have shown to be true in those cases.
I'm not sure off the top of my head. I know that they've just had multiple pain points in trying to consume changes whenever they happen.
Yeah, we should definitely sync with them no matter what, but
in the proposed shape here, Steve, where you had all the abstract versions here. Oh, no, you do have contains. I was going to say, you seem to be missing set contains, or you're just implying the rest of the set interface. But
and those are just the members of the interface lifted to the...
I withdraw my question. I mean, technically, you don't need that else here, because you could redundantly say that you are read-only collection, but...
Yeah, I mean, it doesn't look this way in the ref assembly anyway.
Yeah.
or in the refs rather, because we have in the refs we've got a separate net core file. So iRead-only collection shows up in the main reference.cs, and then we just add iRead-only set in the other one. This was just for an example. I could have done it cleaner.
Yeah. So all of there are places that you're going to be forced to do explicit implementations. I assume they're all so this is the reasonable, like the iSet interface lifted, and then everything else that you have to do as a result of that is just implicit.
Right. So for example, iSet has a .add method that becomes a throwing. It has a remove method that becomes throwing.
iCollection for that matter.
Yeah.
Yeah. And so, but from set, the only real difference is items, instead of being IEnumerable or whatever it says, is you're saying it's an immutable array, so you can use it more strongly here.
Yeah.
And then, of course, the strong type constructor. So, is there anything special in set? Because dictionary, we're talking about the refs, but
there weren't any special concerns. I changed one minor thing. iCollection of t.copy2, that takes an array and an int. It calls them array and array index. I seem to remember in a recent discussion we changed it somewhere to destination. I think maybe when working with span, like when we were adding like span stuff to immutable collections or something. Anyhow, for the parameter names here for the public API on frozen set and frozen dictionary, I wanted to call them destination and destination index. If there's any concerns, I could.
That seems good to me.
One more question I have is like on hash set of t, we added try get values so that if you have, for example, a string like a case case insensitive thing, that you can get back the original casing as it is in the set.
If we want to add that, we could add that. Similarly, immutable dictionary has a try get key or something like that, where it returns to you the matching key that was found, but that didn't seem.
Yeah.
But yeah, if we want to do that, we can do that.
Yeah, I wonder if the contains method should be an in parameter.
General guideline says no one is smart enough to use in public API correctly.
Well, so in imposes nothing on the caller, right?
No, but it complicates code gen apparently. So
the point is, so one thing I was trying to do here is to enable the use of large structs to avoid allocations. So that's why we have the by ref semantics up there. And now
Right.
I notice, I forgot by ref there.
That would also be the case for try get value for try get value as well, then, right, Martin?
Well, if you look at in the dictionary, there's the replacement for try get value is get thing by ref.
No, for the key. If the T key was a large type.
Oh, yeah. For that, I kind of gave up and I said, fine, the key is going to be a reference type. But you could put in everywhere. Yeah. I'm more concerned about the value being a large struct.
Tanner, you have an opinion on frozen set contains taking in T?
Of course, if you make it take an int, it's probably not going to satisfy the iSet requirement anymore.
No, we need an explicit implementation for the interface.
So in is going to be significantly worse for primitive types, the vector types, and any type of class. It will only be better for large structs, and we generally tell people don't make large structs. So I think just taking T is ultimately better. And if we did want to provide something like an NT, we should look at doing that more broadly across our collection types, and be consistent there.
So I'm surprised that if the JIT sees it's an in parameter and the T is an int, it doesn't just pass the int.
So it can't do that because that doesn't match what the user declared. And it will actually change the semantics in multi-thread. Just because the method can't mutate it doesn't mean that something else can't mutate it and doesn't have an alias to it. So even if you pass in int, another thread could have a ref to the same value and then be mutating it behind the scenes. So there's all kinds of complications that can come up.
Isn't it the case that with mutable structs, in parameters are passed using defensive copies?
No, it's when you took it by in and you access anything in a way that is not known to not mutate it. Yes, then a defensive copy is made. It's in looks like it saves you performance, but if you walk off of that knife's edge at all, then it's actually worse for your performance.
Yeah, if the callee calls anything on the in thing that is not read-only, basically, it then makes a defensive copy at the call site to that not read-only thing.
Yeah, at every call. So if you had two fields, and fields it actually knows. If you have two properties, or if you have a property that's not declared with a read-only get, and you took a thing by in, then if you call it multiple times, every individual call is going to make another defensive copy.
Interesting.
Yeah, in is kind of terrible. The guideline is don't use it in public API because when you've learned it was a mistake, you can't fix it.
So in isn't really all that terrible, provided you're using it correctly. But you really are only supposed to use it with large structs, and those structs should be read-only, or all of the members you invoke should be read-only members. That way you avoid all the defensive copies, and it works just like it just functionally avoids the shadow copy that would happen for a large struct otherwise.
Yeah, so my expectation and the guideline we give to our users is structs should be read-only in nearly 100% of cases. It's almost always a bug if you make them read-write. But now I'm worried to say, yes, I'll avoid the defensive copies, but then I'm going to make primitive types suck.
Yeah. Yes, the guideline is do not.
Right. Yeah. Okay, so then
with
look at
this exists for non-public code.
So then you should go back to the dictionary API it's above because it's got several ins, I think, right?
I had none.
There are no ins.
No?
They're
I took the
in
okay.
T, aka int, but no, there are no in parameters.
Oh.
Because we don't use them.
And I don't think I changed that from your code, Martin. I think that was.
Well, I had 4 versions of this stuff over the years, so I guess I dropped in at some point. Okay.
You're smarter than your older self.
Yeah.
Or your younger self is what I meant.
I think that's the right direction.
So ignore the contains then. There's many uses of primitive types and simple types and sets. I don't want to make that slower.
Yeah, and there is for high perf code an argument for exposing some sort of in contains potentially, but the real question is, are those common enough? And is there anything else we could do instead to provide that functionality? For example, with list, we don't really need it because users who really want that extra perf can use collections marshal to get the span, and then they can directly get get a ref or read-only reference via the span indexers.
I mean, the nice thing is these are net new types, so we can kind of decide, who the audience is, right? So if you think most people use these types of large structs, then I guess just saying this contains takes an in is fine. If we think that people will use them more similar to how the other collection types are, but a lot of the members might just be primitives or super small reference types, then it might be not beneficial, right?
So the point of all these is to make stuff faster. So I would lean towards whatever makes it faster.
The problem is faster depends on what key you're using it with, right?
So what happens if I have 2 contains methods, 2 overloads, one within and one without? Is that valid?
Yeah, yes, it is valid. And the we expose those in several places, Jeremy. So what happens is
I just thought you weren't allowed to vary by refness.
well, that's not varying by refness.
You can't have both in and ref.
Yeah, you can't have in and ref, but you can have in and no modifier. You can have ref and no modifier, and you can have out and no modifier.
So what happens on the call side? Do I have to disambiguate somehow?
Yeah. So you have to. So if you have one that's just T and one that's in T, then you can no longer pass. Then you have to explicitly specify in to call the in overload, and the R value semantics no longer function because R values will defer to the just T overload.
Yeah, I thought that was actually that either the language or the runtime didn't allow that overload.
Sorry, Tanner, is it a breaking change if we just add contains T item now, and in .NET 9 we wanted to add contains in T item? Is that a breaking change?
No, that's fine. Because they're two different...
It's a source breaking change, though. Oh, no.
No, because it'd be a new method that you'd have to add the in. I'm just like, when we added in, when we went through and updated the guidelines, we added it to the don't overload based on that. If we violated that elsewhere, then maybe it's a note for v4 to fix. But
yeah, so specifically, we've not done, we've not overloaded based on, we don't have anything that's like ref T versus T or out T versus T. We do have a couple places in unsafe and lower level code that is T versus in T, because both of those are taking inputs, and so you don't have the cute confusing semantics of, well, this one doesn't mutate versus this one does mutate versus this one is actually a hidden return parameter versus an input. So I think the rule on don't overload based on ref out versus T is good, but in versus T is
fair enough.
There's a few places where
we need to before saying we're okay with that going forward, especially on types like our collections types, is we need to make sure that it's not going to break Pascal.net and because the text in there says not all languages can distinguish those overloads. So we need to make sure that we're not applying C# rules to .net.
I think they should be, because this is core metadata. I think if they can't, then there's something wrong.
No, but it could be that from COBOL.net or whatever, it's there's no syntax you could make to let it know that you meant the bival T instead of the ref read only T, and at which point it may say there's an ambiguous method invocation here, I can't call this. I don't know that to be true, but that's what Christoph's prose is suggesting. Is that,
I mean, that might be fair for core types. I think for net new types, I think I'm fine if they can't use those.
Right, but I think if we were going to do something, I mean, here we could decide we were going to do contains T and contains in T.
Right.
But to Tanner's point of, unless we have a proof justification that we need it, we should really wait until we say this is what we want to do for collections. And
the fact that if you can add the overload in a compatible fashion in the future, then let's just do that.
I mean, what I like about having both in the long run would also mean that we could actually have an analyzer that kind of if it looks at the struct and the struct happens to be in your project, we could say oh, the struct looks large, maybe you want to pass it in as in, right? So you can make it a bit more of a, point you to the right things if it actually matters. Versus if you just call it with ins or strings, then by all means just use a regular one.
That works great for anything that Roslyn generates a ref assembly for. The way we generate ref assemblies now will not allow that. That is the way core or .NET Runtime generates everything.
Yeah, our sizes are always opaque. The other one within Tanner, if the struct itself is not declared read-only, so you have read-onlyness scattered throughout the methods, and you call an interface method, does the compiler assume that's mutable or immutable?
Yeah. So if you have a struct and you're calling an interface method via such that you have to box so you box the value type to the interface and then invoke the interface. That will be treated as a mutation or a potential mutation, and that will copy.
So,
but if you directly invoke a implicitly implemented interface member and that interface member is marked read only, that will not mutate.
Right, but if you're generic and you said like where T is I comparable of T, then using a method off of the, and now I'll switch stresses, I comparable interface, it will say, oh no, I don't know what this will do, and so it'll make a defensive copy. So that's one of those places where in just bites you.
Right. So if you have a T, if you have an in T where T is constrained to I collection, for example, and then you do T dot something, that will mutate, and we'd have to add some form of read-only members to interfaces, which requires them rationalizing read-only members for classes.
Yeah. So .NET 12 at the earliest.
So basically what I'm hearing is not now. We can always add it later, which I think is generally fair.
Right, because in this case, it's going to have to turn around and hand it to the comparer, which is not going to take things by in. And so it's possible that taking in at this one level would, on a large struct, save one value copy, but it's also possible that when the contains defers to the other thing, it's like, use the same value copy.
Actually, I have a question there. So in the original implementation of this, there was different types: a frozen ordinal set, a frozen int set, a frozen and the frozen string and the frozen int dictionaries did not take comparers because it's implicit. So Stephen, how do you expect to handle this here?
I have those. You're asking about the comparer property?
Well, and the comparer parameter to the
so the comparer parameter here is used to decide is part of the input to decide which concrete derived collection to create. So if the comparer is null, equality comparer of string.default or string comparer.ordinal, and the T key is a string, then we can create one of the optimal string collections.
Okay. So if you have a collection of ints, a dictionary that ints as keys.
Yeah, if T key is int and compare is null or equality compare int.default, then we can create the int specialized one.
Okay, that makes sense.
It's also worth noting, since none of these are, since none of the methods that could potentially take in are static here, we could, in the future, say something like, we're going to create a system collections, some obscure name that we don't want most people to import that exposes an extension contains int, and then have it, use internals to do the right stuff, and then most users wouldn't have access to it unless they imported system collections. I really want to use performant large structs namespace.
Seems a bit over the top at that point, right?
That's no different than system runtime interop services collection Marshall at that point, really.
Well, assuming it's just APIs that we inject, but if it's net new types, that's what I meant.
Yeah, no, not net new types, but rather just extension methods for I want contains that uses in, but we know that 90% of users shouldn't have access to it and shouldn't be confused by the fact that there's two overloads of contains. We have the option of doing something like extension methods to hide it from most users.
Yeah.
Is that the editor browsable.advanced?
That only item from IntelliSense. That doesn't change that the compiler still has to decide which one you want to call.
That's true.
Yeah. So I did copy in the try get value. Off of hash set, they're called equal value and actual value. I assume we have no reason to change that, but
yeah. So I mean, I don't actually know the scenario for this, but I'm fine adding it. I will point out that we've gone out of our way, like with on dictionary getting a value, we've gone out of our way to make it ref read only. This is by copy, but I also don't have a scenario where try get value on a set needs to be super fast. If we wanted it to be, we would probably want to expose this differently.
The case that I can think of that you would want to use this is if you had a string specialized ordinal ignore case, and this is the what case did I have when I made the set.
Right, in which case a ref read only is not going to matter.
Yeah, so strings are the most common. Okay, what was the key actually? Of if I enumerate the items and I myself ask dot equals this other thing with the comparer that I gave you, what was the thing that's actually going to say yes? And so this is for strings. Basically, it's the case normalization. For ints, it's unlikely that you had a custom comparer, so it would always out itself. And so it sounds like your specialized ones would just say actual value equal value, and in fact, most people wouldn't even bother calling it. So, but okay. Does anybody have anything else? We are over time, so.
No,
I think
this
it's
was
good. I think we should get it checked in, and we can start seeing how people use it and consume it, and we can make tweaks before we eventually ship if we need to.
You don't think we get it wrong the first time?
Don't think we get it wrong the first time. I hope we don't get it wrong the first time, but our track record's probably not 100%.
The core API has been in use for nearly 2 years already, so in a few hundred services.
I'll make these look consistent. All right. In that case, sploop.
We don't often add collections. That's
Yeah, this is fun. It's a good day when we do.
Oh, I forgot that.
Martin, I'll get a PR up soon, and I'll CC you.
Sounds good. Thank you.
thank you.
Thank you.
Bye-bye.
All right. Done. Oh, I can also clear blocking. All right. Well, as you can see from there, I'm the only one left on the call. So thanks for joining us, and we will see you all at the same .NET time on the same .NET channel. And I really like banging my gavel, so